I love single-track conferences. I think that the best conference experiences I've ever had have all been single-track, and it's because you're forcing all these people to sit in the room and hear the same thing at once, no matter what their background is. And I find that there's something so fascinating and so inspiring about just the format. So I'm stoked to be here. So I'm going to start out by telling a creation myth that you all will have heard before, I assume. In the beginning, there was, I don't know, Genesis and the Bible and whatever. But there were users, and there were people who wrote software for users. We were called programmers. We programmed often right there on production, hit save, users can see it. When it broke, they complained to us, we fixed it, and those were the original software engineers. And this obviously lacked some safeguards. Operations is a very manual job, and as software got more complicated, new specialties emerged, like dev and ops and QA, build pipelines, staging environments. The internet became more important and higher stakes, and so we got involved with processes and checklists and all these things. And then the fruit of capitalism, I'm not really sure, the metaphor gets kind of blurred here. But if we take a step back, this is a story about software ownership. And I guess in this metaphor, the coming of Christ is the DevOps movement. Okay, that got a little weird. But we start out by owning our software, right? Because we cared about it, and we cared about our users. And it was a very tight feedback loop there. The people who wrote the code got the feedback, fixed it, and so on and so forth. Because that's how you build great software. And that is how you create jobs for engineers where you have autonomy, where you care about your work, and where you feel personally invested in the consequences and the results. So I feel like now we have a couple of generations of engineers who grew up believing that their code lived in the IDE, not in the real world. And the DevOps movement was, one great blow that was struck to try and change that, to try and shorten that feedback loop, to try and make it so that the same people writing the code, ship the code, debug the code. And the first generation of DevOps was for the first decade, it was basically everyone is yelling at ops to learn how to write code. Learn to write software. I'm okay, got it. And for the last couple of years, I feel like the pendulum has started to swing. And now we're starting to talk to software engineers and say, learn to write operable services. Learn to own your code. Learn to debug it. Learn to understand production, because that's where your code gets real, right? So this means that putting engineers on call, obviously. I'm a huge proponent of that. But when I think about ownership, it can be boiled down to 3 parts. You write, deploy, debug. If you're in ops and you don't write any code, you're not a software owner, right? Because you're just deploying and debugging. If you're a software engineer who just writes the code, but you don't have permissions to deploy code and roll back, or if you don't have the ability to debug your code in production, then you're not a software owner either. But this concept of software ownership is at the foundation of everything that I'm going to talk about today. And there's Jesus, whatever, which is observability. When I say observability, I don't just mean one more synonym for all of your telemetry. There's this old-fashioned definition where people are there are 3 pillars. There's logging and tracing and metrics. And it's well, 2 of those are actions. 1 of those is a storage format. It just doesn't make any sense. It's too generic to reason about. When I say observability, I mean something very precise and technical. But first, let me introduce myself so that you know what my biases are and where I'm coming from. My name is Charity. I am the accidental CEO of a company called Honeycomb. But I've spent my career repeatedly being the first infrastructure engineer to join a startup or a company after it started to become real-ish. Right? Where it's okay, this idea might actually work. Oh, shit, we have to fix it now. I love helping code grow up. I'm also the co-author of Database Reliability Engineering. If you have a copy of that, by the way, and it has a boring horse on the cover, I have unicorn stickers, I can fix it. So see me afterwards. But I've basically just been an engineering manager and engineer for the past 10 years. Also, you can tell I'm from ops because that's how I feel about software. Only good diff is a red diff. And I don't actually come from the monitoring side of the building. I've been in ops, I've been on call since I was 17, and yet I have always hated monitoring, which is not, I don't say that proudly at all. Monitoring is necessary. But Honeycomb is also not a monitoring company. I think of us as being a debugging company and an understanding company. But you should never trust a vendor. As passionately as I believe that, the problem came first, the reason I started this company grew out of all of this pain and the only solution I had ever found. Because of that, I'm a vendor, and you should think very critically about what I'm saying, and make sure that your own experiences match what I have to say. How many people of you are more from the operational and back-end side of the house? How many of you from front end? Okay, that's helpful. That's helpful. So as this first infrastructure engineer to join a company repeatedly, I have been trying to put software engineers on call for about a decade. And I have failed sometimes, and I have succeeded sometimes. I have sometimes failed and then succeeded with almost exactly the same team and exactly the same product. And what I realized is that it comes down to an observability gap. Now, this does not cover all experiences. I have had the great fortune to work with mostly very functional teams, right? I have not really worked on teams that have failed for, the DBA won't talk to the other team, right? That has not happened in my experience. I have had pretty functional teams with their problems, whatever. But the thing that has prevented people from really adopting the software ownership model has been a lack of observability. And again, I said that in a very precise technical way. So let's talk about what observability is in this sense. Now, the definition that I think is most useful, that lets us reason about things, and that is increasingly important, is the one that is taken from control theory. And if you look in Wikipedia, it says, observability is a measure of how well, blah, 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 internal states of the system can be inferred from knowledge of its external outputs. Cool. So when we apply this to software, it means something more like this. Can you understand your code and your systems just by asking questions with your tools? If you have to SSH in and pipe netstat over to some, god-awful regular expression, or run strace on a regular basis, that doesn't count. That's a sign of failure. That's not a sign of success. But with your observability tooling, can you debug your code? Can you understand your code? Can you ask new questions without shipping new code, right? This speaks to the level of abstraction that your instrumentation has been done on. Because if you're instrumenting on the how many of you have ever used Nagios? Only a couple of you. You poor souls. I feel like I can feel your pain from here. With Nagios, it's I built a system. I predict that this system is going to fail in these ways. I will write some janky shell scripts or Perl scripts to check for those conditions to see if those failures have happened. Well, that's useful to an extent, but it is not useful for helping you answer new problems or new questions, right? And then there's stuff like the metrics that you usually get on these dashboards, the net.ipv4.tcp whatever is spiked, and you're like, okay, but this doesn't tell me anything about my problem either, right? It's too low level or it's too high level. What you want is the right level of abstraction so you can answer any question that comes up, any scenario that your system gets into. You should be able to understand it without shipping new code to address that particular situation. And your system is, this is a continuum, right? Your system is observable when your team can quickly and reliably track down these problems without knowing that they were going to happen, without pattern matching them to past failures that they've seen. And if we compare and contrast this to monitoring, the key difference here is that monitoring, because it's been built by ops teams, represents the system as seen from a third party. right? You've got an agent, or you've got, whatever. You're sniffing the network, but you're observing all of these things about the system from the outside. And observability, it's all about instrumentation. It's about getting inside your software and having it explain itself back to you or to your team. And this perspective shift is really, really key in a lot of ways that I'm going to talk about, so I'm not going to go into too much here. But it's the difference between what is the capacity of this tier? Do I need to provision more shit? And why is my user experiencing pain? Because these are very different things, right? Oh God, I can rant about this all day, but I'm going to force myself to stop. These are very different, and for you as software engineers, the thing that you care about is observability because you care about your users and their pain. Your job is not spinning up enough infra capacity to satisfy some abstract ideal. Your job is making sure that every end-to-end request is explainable in some way. And this roughly correlates also to known unknowns versus unknown unknowns. Monitoring is great for the known unknowns. I predict the system will fail in this way, or I've seen the system fail in this way. You monitor for it. Observability is about embracing the fact that you have no fucking idea what's going to happen, and instrumenting so that future you doesn't hate current you. So the reason I feel that this observability gap has existed has been because the tools have been built by ops people for ops people, which means that when software engineers come and look at their dashboards, they mean nothing to them. The amount of submerged scar tissue and painful history that you have to bring to a dashboard to interpret it and draw any conclusions for the code that you're writing is massive. Whereas when you write software by software engineers for software engineers, or from the perspective of the code, you recognize it. It's intuitive to you. You recognize those variable names. You know those function names. You know what's happening in the logic of the code, and you can map your experience to what you're seeing in the graphs. So why now? Why is this suddenly becoming a big deal? This is from 2 years ago at Monitorama. It's this poor boy, he's just like, monitoring is dead. I don't even know what to do, but it clearly doesn't work anymore. And he was right. And monitoring systems haven't changed. What has changed is the complexity of our systems. The complexity of our systems, the ephemeral nature of our systems, the fact that they're dynamic, things are blipping in and out of existence, serverless. A lot of our systems are actually hosted on other people's shit. You have no visibility into how it's working except from the perspective of the code that you've written, right? Complexity is exploding everywhere. And for some people, they hit this inflection point when they adopt Kubernetes or microservices, or they spin up their third or fourth database, type of database. Or there could be a lot of different things. But everybody is starting to hit this inflection point where their old tools that helped them predict what was going to happen and then react to them just don't work anymore. I remember at Parse, are you guys familiar with Parse, mobile backend as a service? Oh, bless you. I was their first infrastructure engineer. I fucking love that place. I am not bitter at all at Facebook for shutting it down. But I remember at Parse, I got so frustrated with these tools because I had all these tools that would answer questions fast, which was great. But usually when I had a problem, I didn't know what the question was. I had a few reports that may or may not be connected, none of which were very precise. And if I knew what the fucking question was, I would know the answer. But I don't know what the question is, right? So complexity. All right, I'm a music major, so I drove this graph. This is a scientific graph for your scientific consumption about complexity going up. You're free to laugh at it, but it's true. Complexity is increasing. I have some architecture graphs that will also illustrate this. There's a lamp stack. Yay. Most of our tools were built for the lamp stack era. They're great at debugging lamp stacks. LampStat being Linux, Apache, MySQL, and like Postgres, Python, PHP, whatever. This is a diagram of parse a couple years ago. That middle blob is like a few hundred MongoDB replica sets. We just let developers all over the world write their own database queries and upload them, and we had to just make them work. And write their own JavaScript. They got to upload it. We just got to make it work without affecting any of the other actors nearby. And here is the national electrical grid of my country. And increasingly, the systems that we are building and the ways we need to think about them are not like this. They're like that, right? They're like the national electrical grid. Some of the problems are you can only find them in hyper-local situations, like a tree fell over on Main Street. Couldn't predict it. Don't know what's going to happen. And it probably doesn't correlate to anything else. Some problems you can only see when you zoom way out. Like if a bolt that was manufactured in 1983, all of those bolts are rusting twice as fast, right? That's a systemic problem that you have to zoom way out to see. And everything in between. But the sheer unpredictability, the unreliability, the fact that failures are constant, and you just have to embrace it. You can't predict it from happening. You would be stupid to try. What are you going to do, prop up all the trees? You can't. I find this profoundly liberating. And it also goes, if you can't see my shirt, I test and prod. Because you have to. Who's going to spin up a copy of the National Electrical Grid to test it? Even if you did, you can capture and replay yesterday's traffic again and again, and sometimes you should. You can never tell what tomorrow's traffic is going to look like. And I feel like a lot of the energy that our companies have been sinking into like this black hole of staging nonsense, engineering cycles are limited. We should be taking some of those and moving them over to harden our production systems to make them more resilient, to make it so that we can ship changes more safely, more automatically, and with less time and effort. Feature flags, blah, blah, blah. That's a different talk. It's fine. The shift also goes along with the shift from where everything was monitor all the things, graph all the things, to the future where monitoring has a place, but observability is what matters. The ability to ask new questions without shipping new code so that you can very dynamically and am I high or did that just... Oh, well, I'll keep going. The next slide says, you're not bad at debugging. Your tools were designed for different problems. And there's a slide that's like the monolith to microservices, the database, whatever, users to developers. And then we say, welcome to distributed systems. And then there's the little dog with fire that says, this is fine. Woo! Yay. Thanks, guys. This is the core wisdom of distributed systems. It's never actually working. Like, if you think it's all up, your tools aren't good enough. There are so many catastrophic states that exist right now in your code and your systems. You just don't know about them yet. Or you do know about them, but you know that they're not important enough or high enough impact to be worth the time of you going and fixing it, right? Imagine if you actually got alerted about every single thing that ever broke. Like, ding, 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 ding. Like, it would never stop. Like, we have to be, like, clear-eyed about this and round up to good enough. It's okay to get a few errors of that type. We can't solve everything. It's fine. But it's still good to be able to explain them, right? So, distributed systems don't have a few failure scenarios that you can check for. What they do have is an infinitely long, thin list of things that almost never happen, except once in a while they do. And these represent almost all of the problems you will ever have to deal with for the rest of your life. So, congratulations. Tracing them down is a black hole for engineering time, which is why, oh, I guess I already ranted about this. You have to do it. You do it. Anybody who says they don't test in production doesn't understand what that means. Anytime that you ship a particular version to a particular environment for the first time, anytime is testing, because it is never, as anyone who's ever typoed production with a K knows, every single time it's a test of some things. So it's worth putting in time and energy to get rid of the really dumb errors. Absolutely. I'm not saying don't test before prod. I'm not saying that at all. I'm just saying there's a lot of things you can't test for. So you should spend some of that precious energy in canaries, in feature flags, in making your deploy tooling robust, safe, easy for everyone to use. And in observability. Yes, also tasty whiskey. It turns out that observability is a missing link in more than a few different things. It's a missing link for testing in production. How much less scary is it to experiment in production if you can see what you're doing? I hope that we look back on the battle days of today when we would ship code and wait to get paged. That's insane. Why would we do that? It should be muscle memory for every developer to ship code and immediately go and look at the graphs of this version versus the other version. What is the difference? Did what I expected to happen actually happen? Did anything else happen? Does anything look weird? If we always spent 5 to 10 seconds doing that, I guarantee 80% of the bugs that you ship, customers would never notice. All of the big, dumb, easy things, if you know what you're... And this, again, comes back to the ownership. This is why the person who developed the code is the only person who can look at that deploy. It's the only person who knows exactly what's supposed to happen, and the only person who's going to have the intuition for what else looks off. Let's look at some examples. This is, any of you who have ever done any ops work have debugged this problem. Photos are loading slowly for some people. Why? And this is assuming the old lamp stack style, right? Here are some example root causes. Can you all read those? I don't see any shaking heads. Database is getting slower. We're out of connections. Cool. Cool. Monitor for these things. Awesome. Characteristics. Known unknowns. Very friendly to intuition. Dashboards are great. You can basically tell the health of the thing just at a glance. And the health of the system is pretty much evenly distributed. If your uptime is 99.8, then 0.2% of the time, someone's getting an error. Best practices are every alert should be actionable. Notify people of problems. You should never have to look at a dashboard. The system should notify you when it's broken. Run books. And, well, not so much a best practice as an inevitability. We debug by looking for clusters of things that are going off. Now let's look at this question. These are real examples that were taken from Instagram and Parse. All right, I'm not sure exactly what I'm supposed to monitor for, but it looks hard. Some of these aren't even really problems that should be monitored for. I've got more. And I could do this all day. This was one of my favorites. They came to me and they're like, push is down. I'm like, push is not down. Like, it's a queue and I'm getting pushes, therefore push is not down. They came back the next day and they're like, push is still down. I'm like, definitely not down, but I'll take a look. Turns out we had added some capacity to our Android push tier, and Androids are supposed to keep a persistent connection open to the pool of services at all times to get, and they were subscribing to get pull-down pushes. Okay, so we had increased the auto-scaling group size and accidentally exceeded the size of the UDP packet size, which is fine, right? It's supposed to fail over to TCP, which it did, everywhere in the world except for one router in Eastern Europe. So everyone in Russia thought that push was down. Again, what am I supposed to monitor for? Yeah, you can't. You kind of just have to laugh and embrace it. You need a different type of tool, right? We're firmly in the realm of debugging here, not monitoring. These are all unknown unknowns. They may have never happened before. They may never happen again. If they do happen again, I guarantee everyone who was there the first time will have left or forgotten about it. Like, these are all going to be new scenarios to you. Characteristics. Unknown unknowns are most of the problems. You have many components. Figuring out which component is at fault is often the hardest problem. Dashboards are usually actively misleading. At best, they make you lazy. The health of the system, this last one is important. The health of the system is basically irrelevant. Imagine that you're running on AWS, and you distributed your system over 3 AZs, and one goes down. You should never notice, and neither should your users. From the perspective of your code, remember, this is the perspective of your code explaining itself back to you, everything's fine. And it turns out that the way that we've built our systems, right, where we're doing all these horizontal partitioning and scaling and blah, 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 there now are all of these little hotspots where, for example, the system might be, if you have 99.8% uptime, the system may be completely up for everyone, except for the users whose last name starts with SHI, because they're on a shard that is completely down. But your uptime is still 99.8. So if you're looking at aggregates, you're like, system is going great. The health of the system in both directions doesn't really matter. What matters is the experience of every single user and every single request. A lot of this, in the LampSec days, a lot of this used to just be a process of figuring out the ways that your system would repeatedly break. And you could move these problems from the engineering problem stack to the support problem stack by writing Nagios checks or the equivalent. You'd just be like, now we've seen it, we'll move it over. And over time, you would pay down the debt so that, if you started here with knowing nothing about how it would fail, 6 months from then, you would have captured 99% of the ways that the system would fail, and you'd have checks for them. It's not that way anymore. Very different tooling. All right, so I've talked a lot about the problem set and the forces that are driving it. Now I want to talk about, at a very low-level technical detail, all of the characteristics of tools that will solve these problems and will actually be helpful to you. And a cynical person might go, aren't those all of the choices that Honeycomb has made? And I would say, yes. Yes, they are, because we have the advantage of being a much younger tool. We had the advantage of seeing at Facebook. We solved these problems. All right, let me give you the capsule summary why I did Parse. So when I was at Parse pre-beta, took it through the Facebook acquisition, and around that time, I was coming to the horrified conclusion that we had built a system that was effectively undebuggable by some of the best engineers in the world. Couldn't be done in less than hours to days. Disney would write in and be like, Parse is down. I'd be like, Parse is not down, motherfuckers. Like, look at my wall full of dashboards. They're all green. Arguing with your customers is great. Definitely improves their experience. But so I dispatched an engineer. I'd go look, and it would turn out that maybe they were doing. There was such a wide range of things that they could be doing. It was insane because we were letting them define their own shit, right? And maybe they're doing 4 requests per second, and they're all failing. But I'm doing 100,000 requests per second. Time series aggregates are never even going to show up on my graphs. So go chase them down. But we were spending 70–80% of our time just tracking down these one-offs. And I tried every tool out there. The thing that finally dug us out of the hole was a thing at Facebook called Scuba, which is a butt-ugly, aggressively hostile to users tool that they hacked together overnight 10 years ago to solve their MySQL problems. It does one thing, and it does one thing well, and that is it lets you slice and dice in near real time on any number of dimensions of arbitrary cardinality. And the amount of time that we took to answer these questions about what's going on went from days to seconds, like a few clicks reliably, repeatedly. And then I moved on, because I'm an ops. I'm like, Yay, on to the next problem. But when I was leaving Facebook, I suddenly realized I no longer know how to do computers. I no longer know how to be an engineer. I can't imagine being an engineer without the type of tool, which is why we made Honeycomb. So yes, we've made all these decisions. Facebook did it first. I'm a vendor. I'm trying to make money. All these things are true. But observability for software engineers in the future. It is 100% an instrumentation game. Cardinality is everything. Dimensionality, event-driven, because it has to be about describing these events, right, from the perspective of the software. Structured data only, and this is about ownership. So, hunting unknown unknowns requires these characteristics of your tools. It is absolutely an instrumentation game. And as an industry, we're still kind of coming up with a way to describe this and to talk about this and to share this that isn't just apprenticeship, right, in the individual level. But it absolutely starts with wrapping every network call and the contents of that network call, whether it's a database query or HTTP query, and the timing information, because that will at least let you narrow down which component is at fault. And then if nothing else, you can attach a debugger or something, right? Like, in a lot of ways, we are scrambling to reconstitute all of the debugging tools that we lost when the monolith exploded. It's about events, not metrics. There are a few reasons for this. First of all, cardinality. Oh my God. All right, so when I say cardinality, imagine you have a collection of 100 million users. The highest cardinality will be any unique ID, request ID, UUID, social security number. Lower, but still quite high, would be last name and first name. Very low cardinality would be gender. And lowest of all, presumably species equals human, right? So when you look at all this information, which types of data do you think will be most useful to you when debugging? It's all the high cardinality stuff, right? Because it's so much more helpfully identifying. And yet, all of the solutions that we've built based on metrics don't support high cardinality. They support only low cardinality, or very limited cardinality. And they'll try and help you understand how to not have this problem. But you can't not have this problem. You need high cardinality dimensions, and you need the ability to combine them. You want to be able to combine, here's an example. Database, because I come from database world, right? Best-in-class tools right now are like Vivid Cortex, where GitHub, when they have a bot that is running wild and causing havoc, they detect it by the high CPU on their MySQL primary. Shit you not. Once they've detected that there might be a bot, they go to their Vivid Cortex and they hit refresh a bunch of times on the top queries page to see if the same UUID pops up a bunch of times. And if it does, then they go look at that UUID to see if there's an unexpected spike of data. Oh my God, that's insane. I first fell in love with Scuba at Facebook because it helped me track down this type of problem. Because you would just sum up the lock time, break down by user ID. Oh, look, that dude is using 97% of my lock time. Boom. Like it's but in order to do that, you have to be able to break down by a field that has many values, like UUID. So, high cardinality is not negotiable. You absolutely need high cardinality in a microservices world. And instead of write-time aggregation, read-time aggregation. Events tell stories. Events are how our human brains work. And events are the unit that your code understands, right? If your code is explaining itself back to you, you want it to be happening at the event level. Arbitrarily wide events are important because the width of the event, what you're saying is all of these values describe one event, or all of these things were true at once. And that is so powerful when you're hunting down outliers, right? Because how many of you have ever looked at a dashboard and gone, this thing is spiking, and gone over here to try and figure out if those events were happening at the same time? Come on. Can't we do better than that, right? All you should have to do is look at which events had that outlier value. The width of events is everything. Structuring your data at the source, it's 2018. We should not still be writing out strings to logs. Makes me so sad. When I say event, I basically just mean a structured log line that doesn't necessarily get written out to disk. Logs, it just has so much baggage, I don't like the term. What about your dashboards? Dashboards are the devil. They're fine for some things, not for debugging. They're bad for debugging. They're actively harmful for debugging because what they do is they give you a bunch of things, and you're like, look at all these things. You start like doing the eyeball thing, just like trying to correlate and like looking for spikes and shit. That is not debugging. That's not using your brain. That's not understanding your systems at all. Every dashboard is basically just an artifact of some past failure. What happens in every postmortem? At the end of every postmortem, you're like, well, let's create a dashboard so that next time we can find this outage immediately. Fast forward by a year or so, how many dashboards do you have? Dashboards are technical debt. I firmly believe that dashboards are technical debt. If you cannot interact with them, if you cannot zoom in, if you cannot ask new questions, then dashboards are actually a liability. They jump straight to the answers instead of even going through the questions. Questions are what matter. Asking questions, formulating a hypothesis about how your system is working and asking that question and getting the answer, that is how you track down problems, following breadcrumbs, and that is how you get to be a better engineer. Unknown unknowns demand explorability and an open mind. You can't have come to it assuming you know what the question or the answer is, because it's going to be something you never thought about. You need to be able to get back to the raw requests. Absolutely non-negotiable. And this means, because we can't create observability stacks that are 200 times the size of prod, this means intelligent sampling. And this means sampling that should be controlled by the client, and not dumb. I'm talking about sampling like for web data sets. 200s to the root URL should probably get sampled very heavily, unless they are by particular customers that you know you want to capture all for. 500s, you should capture all of them. 300s, 400s, they should be weighted. I believe that the curation of sample rates is the new curation, like curating paging alerts. Because you don't need to page yourselves as much. You just need the ability to ask new questions and find the answers. And it's important that this idea that I think that engineers get trapped in, well, what if I have a sample rate and I didn't capture that one event that was a problem? You're thinking about it wrong. An event is not a problem. Assuming that this is not like a transactional or like high security, there are transactional events where you need high fidelity, like replication logs, and those should be kept very not wide, very structured, very compact, and replicated many times. Operational data should be pretty lossy, heavily sampled, very wide events, and treated casually. The problem is not that one event that had an example of the bug that you're trying to narrow down. The problem is the bug, and it will happen again. So tweak up the sample rate, do whatever it is that you need to do. It will happen again, or else it doesn't matter. Who cares about a bug that only happened once and isn't going to happen again? It's just a different mindset. Aggregation should never be done for raw operational data, because when you're aggregating at right time, you are destroying your ability to ever ask new questions about those events. You can only ask the questions that you predicted and aggregated by. When you have smooshed all that detail over what happened in a second down to one value, that one value representing how many, 10,000, 100,000 events, you can never unsmush it. And this is a far worse form of sampling than intelligent sampling on an event level, right? Some of the aggregate kids, they get all, sampling throws away data. You're throwing away data too. You're throwing away more data than I am. You're throwing away all of the context for that number, and you're throwing away all of the other numbers that it represents in that time interval, right? We all have we all have to make decisions about what data to throw away. I think this is the best one by far. Aggregates destroy your detail, your context. And context is everything when it comes to this stuff. You must be able to ask arbitrary new questions about your events on the fly. Aggregating at right time destroys your ability to do this forever. And you cannot hunt needles in haystacks and outliers if your tools don't have these characteristics. Believe me, I've tried. It works to a point, and then you're screwed. Here are some examples of questions that are hard with old-fashioned monitoring tools and very, very easy with observability tools. Like APM tools like New Relic were a huge step in the right direction because they get inside the software's head and explain it back to you. But then there's those top 10 lists. And it's like, what if the one I care about isn't on that list? What if the customer I'm talking to is number 50? Ugh, so frustrating. In the end, this matters because of the users. Users do not give a fuck what your system health is. What they care about is their own experience, and that means events. And circling back to the very beginning, when we were talking about your services need owners, not operators. This observability is a missing link. When you put this in front of a software engineer, it looks familiar. They understand the variable names because they wrote them. They understand the context. They understand what's happening, and they can debug their code in production. They don't have to SSH in, right? The best person to debug any production problem is the person who's working on that code. And it's incredibly important. It is critical that we start building these tools for them. Software engineers spend way too much time looking at code in elaborately falsified environments and not enough time observing it in the real world. And if you don't look at your system when it's working, when it's healthy, you're not going to know what unhealthy feels like. Tighten the feedback loops. We aren't writing code in the end. We are building systems. Everything works in your sandbox. There are so many categories of things you will only ever find when it's your code talking to real services, using real data across real lossy networks in production. So watch it run in production. Get used to watching it when it's not on fire. Or in other words, tonight we test and prod. And that is the end. And I'm 1.5 minutes over my time. So this is the list for the future. And your prize. Like, I'm not going to shit you. Like, it's a little bit painful to get used to a different way of interacting with your systems and debugging your systems. But this is your prize. You can delete like 90% of your paging alerts. So many of those paging alerts only exist because we are not able to debug and ask questions and get to any answer. So we have all of these paging alerts to tell us, oh, it's that thing that broke, which would have taken several clicks to get to. Oh, it's that thing that broke. You don't need them. All you need is request rate, latency, errors, maybe saturation, and some end-to-end checks that stress the core code paths that are what make you money, right? The really core. That's all you need if you trust your ability to slice and dice and find the problem anytime. The end.